Welcome back to the Cave Science, and here we are looking at mole conversions. This is the final worksheet for Unit 5. First question is calculate number of molecules in 200 grams of water. As we mentioned in class, whenever you have grams of something, you got to convert that to moles. So we need to find the molecular mass of water. So we know water is H2O, and so we have two hydrogens, and we have, for oxygen, we've got one. And we know hydrogen has an atomic mass of 1, and oxygen has an atomic mass of 16. So the atomic mass for water is 18 grams per mole. And we want to go to molecules. Well, again, moles is our great equalizer, so we'll have to start there. So we have 210 grams of water. I would like to put things over 1. And we know water, there are 18 grams of water in 1 mole of water. And we're looking for molecules, so definitely we're going to end up using Avogadro's number. In 1 mole of water, there are 6.02 times 10 to the 23rd molecules. And I'm just going to shorten that. I'm not going to write the whole word out, of water. And so if we end up multiplying all the numerators, dividing by the denominator, we come out with 7.02 times 10 to the 24th molecules of water. Again, pretty standard problem. Something you would could definitely see on the assessment. Alright, let's look at number 2. Let me fold this over so we're not looking at 2 problems at once. If you have 6.25 times 10 to the 21st molecules of sulfur tetrafluoride, how many grams do you have? Well, this one's a reverse one, and we want grams of sulfur tetrafluoride, and we've got molecules of it. Sulfur tetrafluoride is SF4. So again, we're going to need what this would be a molecular mass here. So sulfur we have 1, fluorine we have 4, and molecular mass of sulfur is 32, fluorine is 19, and that's 3276. So that comes out to be 108. Well, we've got everything we need now. Now it's just a matter of putting it in form and rolling with it. So we have 6.25 times to the 24th molecules. I'm going to just shorten that down to MOLEC, and it's sulfur tetrafluoride. And we know in 1 mole of sulfur tetrafluoride, there are 6.02 times 10 to the 23rd, and I'll write it down here, molecules of SF4. And we know in 1 mole of sulfur tetrafluoride, it's 108 grams of sulfur tetrafluoride. Well, I'll just put this here. The beauty of the factor label method is you can start canceling out units, and your last unit is what you're looking for. You did the problem right. And if my math is right, and again, don't be afraid to check these, it comes out to 1121 grams of sulfur tetrafluoride. Alright, there's number 2. You can go ahead and define what a mole is. I'll let you do that. Number 4, what is the mass of 3.45 moles of aluminum sulfate? Okay, aluminum sulfate, Al2, SO4, and there's the formula for that. So we have aluminum, we have 2, and again this is the distributive property because this is in parentheses. So sulfur we have 3, and oxygen we actually have 12 on this one, so quite a bit there. Aluminum's 27, that's going to give us 54. Sulfur's 32, and it's going to give us 96. You know, oxygen's 16, 192, and again, don't be afraid to check my math. It's 342 grams per mole. So we've got 3.45 moles. What's the mass? So let's start with what we got. 3.45 moles of aluminum sulfate. And I'm just gonna, well, I guess I'll put all in. Al2 SO4 3. Maybe I like to put that over 1. This one's pretty straightforward. 1 mole of Al2 SO4 3 is 342 grams of Al2 SO4 3. That would equal, and again, if my math is right on here, that should equal 1,180 grams. 1,180 grams of Al2 SO4 3. Alright. Let's see, number 5. Consider zinc acetate. Find its formula mass and its molar mass. Include units for each. To be honest here, excuse me, we're just going to find the mass of zinc acetate on here. I don't know why they broke it up into 2 different things, but we're just going to do find the mass. Zinc acetate is ZnC4H6O4. This is the acetate right here, and there's the zinc. So we have zinc, we have 1, carbon we've got 4, hydrogen we have 6, and oxygen we have 4. Zinc has an atomic mass of, I think it's, let's see, 65.4. So it's going to equal 65.4. Carbon we know is 12, so that should be 48. Hydrogen we know is 1, so that should be 6. Oxygen is 16. And that should end up being 64. And if we add those together, 183.4 grams for that. Alright, that takes care of the first 5 on mole conversion practice, and the next 5 I'll put on the next video.